So this is numbers 7 through 11 on the study guide. So it says, on number 7, find the probability that you have a club. Now, there's no conjunctions here. There's no indicators of the or, given, and then. This is just straight up probability. So we're trying to figure out how many clubs do we have out of the total amount of cards that we have. So if you look at this, in this particular weird deck of cards, we've got that we have 3 clubs, and we've got 10 clubs, 3 of which are a face card, 10 of which are not a face card. So how many total clubs do we have? We have 13 total. Out of how many cards are not a club? So then we want to add all of this up here. And of course we got 52 cards in a deck. So 13 out of 52, which would then simplify to be 1/4. Now looking at number 8, it says find the probability that you have a club given it is not a face card. This is what I'm given. This is what I want my eyeballs to look at, is that it's not a face card. So we're going to look at this row right here, because again, remember, if you are looking at this chart and it says the word given, what is guaranteed? Well, you're going to circle the what is given, circle the information that is given, and then find your probability. So what am I given? I'm given this. It's not a face card. Now, from this information, what's the probability you're going to get a club? Well, there are 10 out of a total of 10 plus 30 is 40 cards that I'm currently looking at. Or, if I simplify that, 1/4. Find the probability that you have a club and a face card. Now, what we want to know is, we've used the word and. They've used this symbol here, so we want to see if this is true. If this is true, then we're going to use this box right here. So that's what we're going to start with. So we're going to look and say, okay, does the probability of having a club and a face card equal the probability of getting a club times the probability of getting a face card? So let's try it. Probability of getting a club and a face card, according to this, here's my club and a face card, would be 3 out of 52 cards here. Now, let's compare that to trying to find this part right here, the probability of a club. So there are 13 clubs out of 52 times, what's the probability of getting a face card? Now, how many face cards do I have? Well, I've got 12 face cards out of 52. And we're going to multiply that out and see what happens when we simplify. So we're going to do 13 out of 52 times 12 out of 52. And when we simplify that, we get 3 out of 52. Look, these two multiplied together are equal to what they have in common, which means these are independent events. Since they're independent events, now we need to go back to this chart. So in this chart, does the intersection equal the probability of A times the probability of A or B? Yes. So what do? Well, our answer is the two probabilities multiplied together, or 3 out of 52. Alright, so then the next one is find the probability of not getting a club or not getting a face card. We use the word or. So since we're using the word or, we want to decide are they mutually exclusive or overlapping, because if they're overlapping, we got to subtract out the overlap. So let's start with the probability of not getting a club. Not getting a club is this one right here. So how many are there? Well, there's 39 out of 52. Or not getting a face card. Not getting a face card is this one here. So that would be 40 out of 52. Now, is there overlap? Did we count any cards that were not a club as well as a face card? Sure did, right here. Not a club, not a face card. That's 30 of them that we counted twice by accident, so we're going to subtract them out. So minus 30 out of 52. And when you simplify that, you're going to get 49 out of 52. That is a good set of chances here. So 49 out of 52. And then number 11 says, are the events of a club and not a face card independent of each other? So we already kind of proved that with this over here, but now we've got a little bit different information. So what do we want to do? We want to see if the probability of getting a club and not a face card is going to equal the probability of a club times probability of not getting a face card. So let's see. What's the probability of getting a club and not a face card? Where's their intersection? What do they both have in common? So club and not a face card is 10 out of 52. We want to know, does that equal the probability of getting a club? So that's 13 cards out of 52 times the probability of not getting a face card. That was 40 out of 52. And do you know what? When we multiply these together, we are going to get this to simplify to be 10 out of 52. So 10 out of 52 is going to equal 10 out of 52. Yes, that works. So yes, they are independent of each other.